This training will go over working with LiDAR using AutoCAD Civil 3D 2020. Topics that will be covered: overview of LiDAR, LiDAR file types, creating and exporting LiDAR in ArcMap, adding LiDAR into Civil 3D, working with LiDAR in Civil 3D, comparing LiDAR with your surveyed data. Little overview of LiDAR. What is LiDAR? LiDAR, which stands for Light Detection and Ranging, is a remote sensing method that uses light in the form of a pulsed laser to measure ranges, variable distances to the Earth. So why use LiDAR? It can be used in conjunction with surveyed points to obtain a broader view of the project design to assist in the approval process. Can you use LiDAR for design work? Depending on your area engineer, LiDAR may be used for some project designs. Make sure that you obtain approval from your area engineer prior to completing a design when using LiDAR only. Some common LiDAR file types that will be used: TIFF, DEM or DEM, ASC, text file, TXT, and an ADF file. There are other file types out there that LiDAR produces that are much larger file types that we won't go over or get into. The ones that we're going to go over are the TIFF and the ADF file types during this training. So you have to create a LiDAR file in ArcMap in order to import it into Civil 3D. So there's some things, if you never opened up ArcMap or you're not familiar with using ArcMap, these are just some steps that you will need to do prior to using the engineering field tools toolbox. And on the state system, some folks may not be able to utilize this specific toolbox. I don't know if it works in the state system, but if it doesn't, most certainly ask someone that's on the federal system to assist you in creating the LiDAR file that you can use in Civil 3D. Or you can download or have them download the toolbox and try using that toolbox in ArcGIS on the state system. The first step you'll need to do is borrow licenses in the actual ArcGIS software. So what you'll need to do is go to the bottom left of your computer screen and click the Microsoft icon. Type in the ArcGIS Administrator in the search bar. That's the two options, I guess. So you can go to bottom left-hand computer screen and click the Microsoft icon, or in the search window, you can type in ArcGIS Administrator. Go ahead and click Open. The ArcGIS Administrator window will appear. In the left-hand column, go ahead and click Folder, Borrow, Return. On the right-hand side of the window, you will check 3D Analyst and Spatial Analyst. Go ahead and click Apply and OK. Then also you want to make sure that you have either a Scratch or a Workspace folder created on your C drive. And also keep in mind that you can only borrow the licenses for 180 days. So with that being said, just make sure that, if you don't use ArcMap, it'll actually give you a warning. So it will tell you that you need to reborrow those licenses or they've been expired. So when you open up ArcGIS, you need to verify the two items below. Under the Geoprocessing tab, under Environments, under Workspace, the current workspace needs to be set to Scratch or Workspace depending on which folder you created. And under the Scratch workspace, make sure this is set to either Scratch or Workspace depending on what one you created there also. And the other step is under the Geoprocessing tab under Environments, make sure that Parallel Processing is set to 100%. The next step would be under the Customize tab, you have to make sure the extensions are turned on. So there's the two extensions that you borrowed originally. So that would be the 3D Analyst and also the Spatial Analyst. So the next step, you'll have to add the NRCS Engineering Tools Toolbox. It is located on our SharePoint site. So if you go to the NRCS SharePoint site under NRCS Maryland Engineering Civil 3D support files and download the NRCS Engineering Tools Toolbox into the C Scratch folder location, or you can put it anywhere. It can just be on your C drive, somewhere where you can refer to it. So adding a toolbox in ArcGIS, there's a little toolbox. If you expand that, add toolbox, or you can right click add toolbox on that. And then what you'll need to do is navigate to wherever you put that folder you copied that into and click open. And then if it's done correctly, you'll notice that the NRCS Engineering Tools 2.0 will be added. And with the two dashed in the front and the back of the name, we'll push that all the way up top in that list of the toolboxes, so you'll know right away it's there because it'll be listed. It will be the first toolbox listed. Before continuing, you must have your DEM loaded into your map. The DEM file is located in the following location under F Geodata Elevation, LiDAR, All Counties. It's highly recommended to copy this file into a folder located on your C drive. You may also have an updated DEM file from your county that you may be using. Just make sure that that file is located on your C drive because it is a lot of information. At the time of this training, this is the current location of where the LiDAR is located. So before opening ArcMap, you can type in the search bar ArcGIS Administrator. Or you can just click the Microsoft icon, go to ArcGIS folder, and you'll notice ArcGIS Administrator is the second item down. This may or may not be expanded, so you might not see that bar return, so you want to expand the desktop. Bar return, and you'll notice that it defaults to 180 days. Like I said earlier, 30 days what it used to be, but they've upped that to 180 days, so I would just check it for 180 days. The two that you want to worry about are the 3D analyst and the spatial analyst. I do have two others checked which you don't need to check. These are the two minimum ones that need to be borrowed. Go ahead and click those to borrow, click apply, and then go ahead and click OK. I've already borrowed them, so that's why I came up with a little bit of an error. So now you can open up ArcGIS. Again, you want to make sure that you have those two folders made up in the C drive, either C Scratch or C Workspace. And in this case, I've already done that. So the next step would be under Geoprocessing, under the Environments, under Workspace. You just want to make sure that your current workspace and your Scratch workspace points to one of those folders that you created, if it's Scratch or if it's Workspace. The next step would be to go down to the parallel processing and double check that's set at 100%. If not, make sure that you put 100% in that. Go ahead and click OK. And then the final step would be to customize. And then you want to go to your extensions and double check to make sure that you have 3D Analyst and Spatial Analyst checked. The next step would be to add your toolbox. So if you go ahead and click the Arc Toolbox icon, it'll open the Arc Toolbox folder. And depending on where you have that docked, it might show up on the right hand side. It might show floating. It's almost like Civil 3D where you have the different toolbars that will be docked or not docked. So once you do that, right click the Arc Toolbox, add Toolbox, then navigate to where you place that. In this case, it was placed in the C Scratch. Go ahead and click Open, and then it'll add that toolbox into your toolbox folder. and you'll notice there are some different tools, 4 different folders that are in that toolbox, and we'll go over mainly the field office tools in this exercise. So the next step would be to add your DEM file. So you can right click your layers in the menu and navigate to your FGeoData. If you don't have that, you'll need to add that connection. So in this case, I don't have that specific connection. So I'll go ahead and add that and just navigate to your folder. This PC, under the F drive, under Geodata, click OK. And now you'll notice that I have a connection there. And then once you connect to it, you'll notice this is all the folders located in the Geodata. Then you'll navigate to the elevation folder, and then the LiDAR all counties, and then choose whatever county you're in. And then that will add that layer DEM file to your folder. It might give you a warning, but just go ahead and hit close and it'll add that to your GIS drawing. One thing to keep in mind, this is a large file, so it'll stay on. I would just recommend unchecking that. And again, with all of this, we want to make sure that we want to copy that and put it into your C drive. So the process that I just showed you was grabbing that DEM file from the F drive. So you want to make sure that you want to save that into your C drive. Otherwise, it'll take a lot of time and to process that data. What I showed you was just going directly to the F drive, but the recommendation is just going into the F drive under whatever county you're in. So copying that onto your C drive will make it much more faster when processing the data. And if you want to make sure that you are on the C drive, that your data is coming from the C drive, you can just right click on the properties of that specific layer. And in this case, it'll tell me the file type and where the folder is at. This is just an external drive that I work off of. And then this is just the folder. Just keep in mind that LiDAR, that DEM file is very large, and you want to make sure that you have it off when you're running these tools. If not, it probably will crash your system. And make sure that it is on a C drive or external hard drive, whichever's easiest for you. So the next step will actually be using the NRCS Engineering Tools Toolbox. If you expand the field tools, the first folder, that's what we're going to be concentrating on this exercise. We're just going to go ahead and clip the DEM to AOI. So we're just clipping the digital elevation model to the area of interest that we create. So once you select that, a little window will pop up. You have to make sure you select the correct input DEM. If it doesn't give you the DEM file as an option in here, you don't have that loaded into your ArcGIS. So make sure that you load that DEM into your current project in ArcGIS. Select your DEM and then go ahead. The next step would be to draw your area of interest. And it doesn't give you any type of, you don't drop down and select anything. It's just you got to select outside of that window, and then you'll notice that a cursor will come up, and then you just select that box or area that you want to clip to. And then your output DEM, just go ahead and select again the C scratch or the C workspace, whichever folder you made up. And also I'd recommend making that folder of what you're working with first before you actually do this. And the reason being, sometimes it gets a little finicky of, you can create a folder while doing this on the fly, but it's easier just having that folder made up prior to you doing this process. And then go ahead and select that folder, click OK. And then this would be the final outcome of that clipped AOI. So in ArcGIS, we have our toolbox here. The first folder, Field Office Tools, clip DEM to AOI. You can double click that. And I'll bring up your window. Again, your input DEM would be the DEM that you have loaded currently in the drawing. And then as you can see here, there's nothing, as far as dropping down. You just keep this to the default. But once I go outside that window, you'll notice a little crosshairs come up. And then we're just going to select this area to clip to. Double click to finish the command. And then your output DEM. Again, it's always better to have, that folder made up. And depending on, what you're using, in this case, I've got C Scratch, but a lot of my drawings that I do, I have them under the CFOT that I've made up. But in this case, we're just doing the C Scratch, and then just the training AOI, and then I can, name that whatever I want. Go ahead and click Save, and it should, give you the folder location down here. C Scratch Training AOI. Keep in mind, there's a limited number of characters that will give you an error, and if there's no red X here, you should be fine. But I believe it's up to 13 characters, so try to keep it below that. They might have changed that, but I remember from the previous tool that was made in the past that there was a limited amount of characters that you can put on that. And then just go ahead and click OK. So this would be the clipped AOI from the DEM. It'll automatically make that DEM file clipped, and it'll give you the values, the high and the low within that DEM file that was created. Now that you have clipped your DEM, you can now export it as a TIFF file. Go ahead and right-click the clip DEM file, Data Export Data. Window will pop up. Go ahead and pick the location, name and format, and click Save. So in this case, the location, it's just going to my C Scratch. In your case, you might want to put it in the C Scratch first and then take that and put it into your working folder, but it needs to go into the working folder that's uploaded on SharePoint. Create the name and the format. Just make sure that it's a TIFF file. Go ahead and click Save. You will get a message on the output raster. Would you like to add the exported data to the map as a layer? You can go ahead and click No on that. So when you open up your file, you'll see the .tif and the .adf file formats that you can upload into Civil 3D. So you'll notice here, when it's created that under the C Scratch LiDAR training folder, it will have a hdr.adf file type and also the LiDAR training.tif file that we exported it as. So when it creates the actual DEM file, the clipped version, it will have this hdr.adf file already in there, and it'll have a couple other ones in here. I think there's 5 or 6 different file types in there. It will not have the .tif file in there. So that's where, coming back here, when you go into your location and you export that data by hitting Data, Export Data, we're creating that TIFF file format in that folder. Otherwise, if you don't do it that way, you can still add the LiDAR into your drawing just by, once you create that clip file, you can add that into your Civil 3D. You don't have to make it into a .tif file. I just find it easier having that file that you can, it's one file that you can just drag and drop into your current working folder. Whereas if you don't have that TIFF file and you have the other file that you use, and you have to take all those folder types and add that to your working folder when you submit that design. So I just find it easier creating that TIFF file because there's less file types that you'll have to transfer over to the working folder and uploading to SharePoint for review. Once you have that completed, you can go ahead and close ArcMap. So going through the process of exporting this folder or this clipped DEM file, again, if you right click on this and you go to properties, it'll tell you C scratch and it's called LiDAR training. So it's just in the C scratch folder. So if I were to navigate to my C scratch folder, you'll notice that I've already created the LiDAR TIFF, but you'll notice that what it does, it just creates, there's like 4 file types in here. I believe it's the HDR, the PRJ, the STA, and these 2, one with an X and one without an X. So there might be 5 file types in there. So you could definitely, take this without going through the next step of the TIFF file and using that to import LiDAR into your Civil 3D drawing. The only reason I do the TIFF file is to reduce the amount of error of making sure that you have all the files copied and pasted into the working folder to upload into SharePoint and work off of. Because right now we're working under the C scratch, that's where that file location is located. And if you were to do all your work, submit that in, it's going to give you an error in Civil 3D saying, well, this is located on this person's name under the C scratch folder or workspace, whichever folder you created. So you have to make sure that you bring this data into your engineering working folder when you upload it. So to export it as a TIFF file, you just right click that DEM file and you go to data, export data, and you just have to go and select where that's at. So in this case, we have that training AOI that I've created. You can give it a name. And as you can see, once you say, the object, it's trying to find that because we're selecting that workspace. So that's where you have to actually create a new folder in here and call it LiDAR clip. Go ahead and click add. And then now we're under training AOI LiDAR clip. And then we can call this whatever we want. Make sure the file format is set to a TIFF. I leave everything else the same. Go ahead and click save. And then it's going to ask you, would you like to add the exported data to the map as a layer? I always select no. And most of the time it does it pretty much instant. So if we were to go into our C drive again, and then we go into our scratch, and then LiDAR clip, you'll notice that there's a LiDAR clip.tif file. And you'll notice there are other files with this, and you can just copy the .tif file and have no problems. You can just copy that specific file over into your drawing and also into your working folder. So the next step would be to take this folder or this file, and you can copy this, and then whatever you're working under, under your drawing, if it would, in this case, it would be under your working folder, but in this case I'm just showing you that I'm putting it into another folder that I can use. And again, this is the same TIFF file that I made before, but that's all you have to do. You just have to paste that in there, that TIFF file. Once you've completed that process, you can go ahead and close down ArcGIS, unless you have to make a watershed or something like that, but this is specifically geared towards just grabbing that DEM file to import into Civil 3D. So we can now close down ArcGIS. So now that you have your file created and exported into the correct file location, you can now open up Civil 3D. Make sure that when you open up Civil 3D that you are opening up a Maryland template. And the reason being behind this is that the templates already have a projection set to them already and will import that data correctly. So as you can see on the screen here, it's already set to the US foot, Maryland State Plane, NAD 83. And also keep in mind the size of the file that you have generated from your LiDAR. You don't want to make the file size too big because it will slow down Civil 3D. So before you import your file into Civil 3D, make sure that you copy the file into your working folder as we discussed earlier. And this will be the location that you will use to import the file from. Just make a habit of doing that. Don't import it from the C drive. You want to create it onto the C drive, but you want to work with that folder from the actual working folder that you're using your design in. That way it's done correctly when you import that. So here's the LiDAR area that we created, that we clipped to. So to create the LiDAR surface, just go ahead under the Prospector tab under Surfaces, create surface. So you can just right click, create surface. And then the new surface window will appear, create surface window will appear. Name that surface to whatever you'd like. In this case, I just named it LiDAR. The style, you can select whatever you want. And again, these are, things that you can change. So don't feel that you're set to these when you put these in at first. In this case, existing contours 1 and 5 was the style that I selected. Go ahead and click OK. Expand your surfaces once again, and you'll notice that you'll have the LiDAR surfaces. Expand the definition, and then go down to DEM files and select Add. And then you want to collect the little icon that shows the DEM file, adding it to adding it to the actual folder. So you want to navigate to that folder. You don't have to worry about this. This will auto populate once you bring this in. So you want to navigate to that TIFF file, and at first it might be a ADF file or it might be a text file depending on what type of file you imported the last time. So you just want to make sure if you don't see that popping up, the .tif, you got to make sure that you go to the files of type and go down to .tif. Once you do that, you'll notice that your TIFF file will show up. Select that file, click open, and then you'll notice where the file location's at. In this case, it's on my C drive, but others, it should be in your S drive under working under engineering projects and the file name that you're working in. It does give you an estimated point total here as far as your description, but it does give you the NAD 83 state plane. Go ahead and click OK. And if you're in the location already on your map, you should see it right away, just like you would do with any other type of surface. So it should show you where it's located. If you're in that map area, it will show up right away if you've done it correctly. Otherwise, if you're not, if you're zoomed out, you can right click and zoom to your surface that you created. The other thing to take in consideration is the level of detail. If you have a large area of LiDAR and your computer is running slow, you can turn the level of detail on to speed up the regen process. So in the command line, you just type level of detail. This will turn it on and show less information the more you are zoomed out. To turn it back off, in the command line, level of detail off, and it will give you like a warning that you're exiting the level detail display mode. And if you don't want that to be selected, you can hit the check mark to do not show me this message again and hit close. And then the next step would be to simplify the surface. This is good because if you do have a lot of information, a lot of point data, it'll reduce that surface size so it speeds up the process. So once you select your LiDAR surface, the contextual ribbon will pop up and you'll notice edit surface, and then go all the way down to the bottom where it says simplify surface. And then the window will pop up, and there's 3 steps to this. On the first one, simplify methods, and the method that we're going to choose is point removal, so you want to make sure you select that. Go ahead and click next. The region options, just use the existing surface border, so in this case it would just be that square box that we created that clip DEM file from. And then the reduction options, you want to select the percentage of points to remove. In this case, you can go up to 90%, and the maximum change in elevation is probably the most important one to select here. Is you don't want to change it more than 1/10 in an elevation. So go ahead and click apply, then finish. So we'll go ahead through the process of adding the LiDAR surface. So we want to create the surface, right click on surfaces, and we can label that LiDAR. Our style could be existing contours 1 and 5 for this example. Click OK. So it's created the surface and prospector. Expand that, expand definition, go to DEM files, right click, add, and then we're going to navigate to that file location. And in this case, we did the LiDAR clip. Give the estimated point total 386,000, state plane. And then these are matching up correctly at its state plane. It would show an error if this doesn't work correctly. Go ahead and click OK. And since we're already in that location, it's showing the DEM file automatically, that surface. And you notice as I zoom in, it gives me the LiDAR elevation. And I do have an existing ground elevation in here, but it gives you that LiDAR elevation. So it is a surface that, is fully functional, just like you would have if you went out and surveyed the site. So the next step would be to go in under the level of detail. So if you typed in level of detail, automatically turns it to off. And as you can see, when you have it off, the further you're zoomed out, the less lines you see. But as you zoom in, the level of detail becomes, there's more information shown. So if you do have a lot of relief in the DEM file, you might want to turn that level detail on, meaning that, it's not showing that much detail when you're zoomed out. It just speeds the process up. And to turn it back off, level detail, level detail off, and it'll give you that message saying that you're turning it off, and then you'll see all that information displayed. The next step would be your simplifying of your surface. So select your surface, and you'll notice the contextual ribbon will pop up. Edit surface, simplify surface. We want to select the simplify method being the point removal. So we're just removing points from that surface. Click next. The region options, we're just going to use the existing border of our DEM file clip of what we brought in. If you wanted to do a certain area because it had a lot of information or data or relief, you could specify a polygon or an object within that drawing. And then again, we can jump this up to 90%. So you can click that and also click the maximum change in elevation. So right now it's 0.01 and we just want to change that to 0.1. So we don't want to change it more than a tenth of an elevation within that area. Hit it finish, or you can click apply and you'll see how many points have been removed. So if you click apply, it's simplifying the surface and it's saying total points removed 131,993. So now currently we have 19,282 points within that region. And I think we started out with 382 points or something like that. Go ahead and click finish. And you might see adjustments to your surface a little bit. Again, all depending on, what you're using the LiDAR for, depends on, the processes of what you're going through. And in this case, we just wanted to use this LiDAR to expand our survey region. So that's why we're simplifying this surface. But if it was something that you were using, a design for, maybe a pressure line system, maybe you don't want to simplify that surface. Maybe you want to keep it, relative to what you have. If it's not crashing, then I would recommend just keeping it the same way it is. Long as you don't get such a large area. I've just seen sometimes where when you bring in LiDAR, if you're concentrating in this area right here that you're doing the design, just limit your LiDAR that you're doing that design into that area. But in this case, this was a surveyed area that we've done, and the area engineer was asking for additional topography outside of that to make sure that water was not coming into the area that we were designing, the specific BMP at. Make sure that, whatever you're using that LiDAR for is, relative to what you want to have shown. So if you want, a high level of detail that you're using a design for, then I'd recommend maybe not doing the simplified surface and concentrating, specifically in that area where you're doing, a pipeline or something like that. And, you can estimate if that pipeline is running down this way and, coming across or what have you. You can just do that area just so you're able to put in alignment in that specific area. And then you can create another LiDAR outside of that if that reviewer would want to see more topography outside of that area. I guess my point is just make sure that whatever you're doing, that one, you get the okay from the area engineer that using LiDAR is okay for the design, and two, reducing that or simplifying that surface is okay to do if you're just doing, a broader view of that actual design. So if you did have a surveyed site and you would like to show contours outside of that area, you can now clip the surveyed area from your LiDAR surface. Just keep in mind that the elevations may not match specifically to the LiDAR, depending on, if you shot it through GPS or if you just, shot it at an assumed elevation. The LiDAR contours are basically there to show the big picture of the design. Although you can adjust your LiDAR elevations, which we're going to walk you through this, although you can show or adjust your LiDAR elevations to fairly match what your survey data is. So in this example, this is the area that was surveyed. This is the LiDAR that we brought in purple. So the red line indicates the area that was surveyed, and we want to clip that out from the LiDAR. So we show our actual survey data because we know that's the correct elevations that we want to use. The LiDAR really doesn't match up to our elevations. It's, 4 or 5 feet off for whatever reason. So you can clip out that surveyed area shown by making a boundary and then selecting the hide. So now you have your surveyed area in the red box and then the LiDAR on the outside. And again, this is giving your big picture to the reviewer, so having an understanding of what way that water is flowing. So this is showing the LiDAR and the surveyed surfaces along with the map. So you see the points in there. You see your existing contour layers based off of your point surveyed, and then the LiDAR on the outside of that red line displayed together. So you can adjust the LiDAR surface elevation to match your surveyed area elevation, and like I said, it'll be close. So to adjust your LiDAR elevations to match your survey data, you can raise or lower the LiDAR surface. So based on the survey data, we need to lower the LiDAR surface about 6 foot to match the survey data elevation. So kind of pick your elevations here, and you can kind of see this is 350, 357, 351, 352, 358, and it's going to be close. And we're just using this for, giving the reviewer a more broader view of the area. But if you were to have to use this to extend a profile or something like that, you can then add that LiDAR surface into that profile view to extend that alignment showing the LiDAR if you match them up fairly close. Now, if we didn't adjust this LiDAR elevation, then, if we had an alignment that went from, 350 and went across, there would be 7 foot difference, from LiDAR to your existing elevation. So this is just kind of getting it closer to what's actually was surveyed. So to do that, under your LiDAR, under definition, under your edit surface, LiDAR surface under edits, you want to raise lower surface, and in this case, you can do 6 foot. It could be 6.2, whatever. I mean, you can choose whatever you'd like to get it close to your surveyed surface. In order to lower it, you need to use a negative sign. Otherwise, just write in the elevation and that will raise it. So in this case, we're just going to lower it. So we're going to put -6 and then hit enter. And you'll notice that, here's 351 matches up close to our 351. Here's 352, 353, so on and so forth. So it's getting closer to what, it's closer than what it was. Keep in mind that once you adjust the elevations of LiDAR to match your survey data, if you're going to go out and complete a survey using GPS, those elevations will not match to your adjusted elevations. You must then localize that survey to the elevations that are adjusted to your original survey points. So now we're going to go ahead and clip out our existing survey LiDAR, or our LiDAR from our existing survey. So just for reference purposes, I just made the existing surface future contour style type, just so you can kind of see the purple. And then if you notice here's my existing surface that was actually surveyed with points, locations. These were actually surveyed points. I want to keep those surveyed points. I don't want to adjust those. I want to adjust the LiDAR to match that. So we have this boundary that was created going around the outside of our survey boundary that we want to basically trim our LiDAR to. So if you go into your LiDAR, and you want to go into definition, you want to add a boundary, and we can just call it outer. And you just want to hit hide, click OK, select that surveyed boundary, click enter. Regen, and you'll notice that the purple is now taken out, which is your LiDAR, has now been taken out of that surveyed area. So even though we've taken that out, we've hidden it, it's only going to show our existing ground of 343.595. So we're hiding that information. So once we go out our survey data, you'll notice it pops over to LiDAR, so that's the other surface that it's jumping to. So now we want to adjust our LiDAR based off of, what our survey data is, so it would match up a little bit better. So we can adjust that elevation. Again, this is just, coming in contact with, here's an elevation here, for example. This is 333.7. Once we jumped up the LiDAR, 338.9. It's about 6 foot off. And that's what we're just doing in this example. So this is 335. This is 341 approximately. So, LiDAR needs to be adjusted down 6 foot to match better with our surveyed surface. So to do so, make sure that you're in the LiDAR surface under Edits, and you can right click, raise or lower surface, and then it'll ask amount to add to all elevations, or raise lower surface amount to add all of the elevations, depending on if you had the dynamic input on or not. It'll show you on your front of your screen. And in this case, we're lowering the surface 6 foot. So we'd have to put a negative sign in front of that and 6 foot. Hit enter. And now, if we were to take this at 334.952 and come over to here, 335, it's fairly close now. So if you were to do an alignment, it would better represent, what the LiDAR matches up to of your drawing. This will now conclude the training on working with LiDAR.